Fun little video today. I want to show you the heat that these different polishers can produce. Anything from a polisher with an 8mm throw here to a 15mm throw, 21, a force-driven, gear-driven, so it oscillates and rotates, and then a rotary polisher. And I'll show you the temperature that each one can produce. We're going to use different polishers, but we're going to keep using the same pad and the same polish. Now this pad has a hole in the circle, which with some polishers will let heat escape and run cooler. The first polisher here, I want you to see that the backing plate does not have a hole like the other polishers do in the backing plate. And then the backing plate also has ways to vent air and heat. The 8mm polisher should be the coolest, you would think. Which one do you think produces the most heat? Which one do you think runs the coolest? You could see the ambient temperature here on this panel is 70 degrees. I have a scanner here. Now, the crisscross in the middle is where we're pointing the scanner. There is a red and a green bullseye. The red shows you the hottest point of the picture, and the blue one the coolest point of the picture. I'm going to insert my hand so you can see they're going to pinpoint. The red is going to go to the hottest point of the picture, and the green will go to the coolest point of the picture. Remember that through the video as I bring the scanner into the fold here. So we're going to start with the polisher with the 8mm throw. Now remember, this one has a backing plate that doesn't have a hole in the middle. It has a solid backing plate. So all the heat from the polisher and the heat from polishing the backing plate, the panel, and the pad will be stuck in the center of that area that you're working. I'm going to have the polishers run at the same speed, same pressure, same correction rate, an inch every second or two, so everything will be as close as I can keep it as we switch polishers. But the temperature readings you're going to notice will be different. Take a look. Just with this entry-level polisher, temperatures can spike 170, 180, 190, up above 200 degrees. That's crazy because I'm going to bring in the scanner and you're going to see the ambient temperature, the temperature of the rest of the panel, is going to be room temperature. And that is way too much of a jump in just a small area. Way too much stress, and the clear coat and the color coat can fail. There's a chance it can fail. The chances may not be extremely high, but why take the chance? Showing you the surface of the pad, white hot. Let's move along to a polisher with a 15mm throw. A little bit more energy being transferred from the polisher through the backing plate, through the pad to the surface because of the longer throw. However, with this polisher, the backing plate has a hole through the center and there's venting. So there's somewhere for that hot air to escape a little bit. Is there going to be a difference? Well, as you can see here, there is a bit of a difference. Even though the polisher can produce more energy and has a potential to produce more heat, just because of that little engineering addition that they added to the backing plate, it runs cooler. And take note on the bottom left of the scanner here, it shows you the hottest portion of the picture and where it is. Bottom right shows you the coolest area of the scanning area. And then we have the crosshairs in the middle, shows exactly where the tool's pointed. Let's move along to a polisher with a 21mm throw. So the oscillation is a bit wider, the throw's wider. There's a more powerful motor for this polisher, you would think. With all of that power, all of that energy being transferred from the tool down through the gears, backing plate, and pad to the surface, that there would be a ton of heat. Well, we shall see. When in reality, it runs within that 20-degree cushion that we have between the ambient temperature of the panel itself, which is between 75 and 78, and 90, 91, 92, maybe mid-90s at the highest. So that is within reason, and that keeps a little bit of the stress down on the panel as well as you're correcting.
Saw his email, but no, he doesn't. He doesn't seem to like. He's not asking. No, no, not
The
immediately.
next machine, the next polisher
Yeah,
is forced rotation or
yeah.
gear driven, and it rotates and
Other
oscillates
than that,
at the same time.
pretty much it. But yeah, I'll forward you. I'll forward you the email from the guy that received the last polisher. He's soldering the little probe. Yeah, I. Well, yeah, it's not me. It's my buddy. He's on the dinner. He's on the phone with me.
The flex polishers put a lot of engineering into the build, inside, outside, the plastic casing, down through the gears into the shroud and backing plate. There's a ton of air circulation, and this does a fantastic job keeping the area cool that you are correcting. The point of making this video is to show you there are a lot of bad choices that can be made when it comes to choosing a polisher. Uh, there are, of course, economical reasons to choose a polisher, but do your homework. Check the build of the polisher. Does the backing plate have a way for heat escape? Does the shroud above the backing plate have a good way for heat to escape? The pads you are using, all of that can come into play when you're doing paint correction. And I wanted to show you this. Let's move along finally to the big bad rotary. And I would guess most of you have the rotary down here as the tool that would produce the most heat while correcting. Well, let's see.
No problem. Just reach out to me anytime. No problem, man. Anything else? Oh, you as well. Great to meet you, man.
So the rotary polisher is up there amongst the coolest running polishers, not only because of the build. There's a lot less going on. There's just rotation of the gears. There's more going on with the dual action polisher when it comes to the gearbox, and it produces more heat. Also, because of just the rotation of the pads, there's a lot of airflow that helps keeps things cool as well. So always try to fit a rotary polisher in with your arsenal. Now, you could choose to ignore temperature, throw caution to the wind, and I'm going to show you what can happen when clear coat fails. There can be peeling. We've seen this before. This happens naturally when the prep isn't done right. This can also happen when the clear and the color coat are put through a lot of stress and they expand and contract in different ways. Oxidation, crow's feet, and burning through the paint. So I hope this helps. Just put a little bit more research into pad choice, backing plate, and polisher choice and keep things cool. Brian from Apex Detail, catch you in the next video.